In this, we are having a crank over which there is a load of 200 kilonewton. That is the difference here. So because of this eccentricity, uh, there will be a vertical load of 200 kilonewton acting at point C, as well as a couple. Now this is on the right side, right? The crank is towards the right side. So the couple magnitude will be equal to 200 into zero point 0.5. That will be 100 kilonewton meter. And because of this eccentricity, it will be in clockwise direction, right? So two things we have to replace with this eccentric load. One is vertical force of 200 kilonewton. Another one is at the same point a clockwise couple or moment equal to 200 into zero point 0.5, right? That will be 100 kilonewton meter in clockwise direction. So in your exam, this is an exam numerical, by the way. So in your exam, you may get a crank like this, or you may get a couple directly. There are some numericals like this. I don't know if it is there here, right? So there can be a couple directly given, or it can be indirectly given like this. So in both the cases, we have to do the same. The couples are handled in the same way how we are going to do it today, right? Now let me first uh, modify this load diagram, right? So how are we going to modify? I'll just copy this part. I'll just move it here, and this thing I will just delete it. Right now, this force I'm directly applying on point C. Also, there will be a clockwise couple. So I will show like this. So see, the load is like this, so it will be clockwise couple like this. About this point C itself, and the magnitude of this will be 200 into zero point 0.5. How did we get that? This distance eccentricity is 0.5 meter. 0.5 meter multiplied by this 200, so that is 100 kilonewton meter. That is the magnitude of the moment of the couple, right? So now my modified load diagram is ready. I can start solution to this. Solution: the eccentric applied at C can be as 1, a vertical force of magnitude 200 kilonewton and a clockwise couple of magnitude 200 into 0.5. I'll put the unit also so that it is much clearer. 200 kilonewton into 0.5 meter equal to 100 kilonewton meter, right? Acting at point C. ठीक है? So this is shown in the modified load diagram below, and this is my modified load diagram. Now with this, I have to find the support reactions. Now, after finding the support reactions, I have to do what? Take a section in the extreme section, that is BC, somewhere here, and based on that, I have to calculate various things. Now, let us start support reactions. Taking about point A. Now I'm taking moment at this point. So from here I will have RB into 4 plus 2 is 6 meter minus 200, that is this force at C, into 4 meter. Now you see this is clockwise couple on the right side of the section. Now if you see, this downward force is also making a clockwise couple. So right side clockwise is negative, so minus, this is 100 kilonewton meter, 100. So don't do 100 into 4, right? So this is a couple, there is already the unit is kilonewton meter. You cannot say kilonewton meter into meter. So this will be equal to 0. Now from this, RB is equal to, let me calculate this. So these two will come on the other side as positive. 200 into 4 plus 100 is 900 by 6. So that is 150 kilonewton, and RA plus RB should be equal to what? So these are the upward forces, that should be equal to sum of downward forces. There is only one downward force. In the force calculation, you are not supposed to take the moment of the couple. So that should be equal to 200 kilonewton, or RA is equal to 200 minus 150, which is equal to 50 kilonewton, right? So I have found the support reactions at both the supports A and B. Now we can proceed with the bending moment calculation. What I will do, consider a section XX at a distance of X meter from support A, right? So I'll just show that. So this is my section XX, and from A this length is X, right? And this length will be X minus 4. So there are only two. I'm not going to spend time on modifying the diagram because we are running out of the time. The bending moment at this section is given by I'll call this as mx, and that is equal to, okay, this is my section. So let us start from here. So it is RA into X, and RA is 50, 50X, right? And other things will be negative. Now this will be negative and this will also be negative. No, this will be positive. Yeah, 100 kilonewton meter, that will be positive, but 200 kilonewton into x minus 4, that will be negative. So 50x minus 200 into x minus 4, correct? This is 200. This distance from C to X is AX minus AC. AX is X meter and AC is 4. That's why I've taken X minus 4. And this will be positive. So plus, this is 100. Right. Now, while finding the deflection, we need the distance. Whereas in case of um, slope, I don't need the distance for couple. So another rule in Macaulay's method is, whenever you have a couple like this, you multiply here with the distance, that is x minus 4. Now if I just leave it like this, the bending moment definition will be wrong, right? So this is already kilonewton meter into meter, so it will become kilonewton meter square. So it is something different, which is not equal to mx. So what I will do is, I will raise this to power 0. So anything raised to power 0 is equal to 1. So 100 into 1, it is not changing any meaning, right? So just keep it like this. This will be kilonewton meter. Also, mx, I'll just copy this. Mx is equal to EI into d square x set by dx square. Right? Now equating both of these equations, we get mx is equal to, I'll just copy this entire equation, right? And I'll call this as equation 1. This is not required to number this. Now I have to integrate this equation twice. Equation, we get EI dy by dx is equal to 50x, right? So it will become 50x square by 2 minus 200, x minus 4 is there. So I have to consider this as whole. So it will become x minus 4 whole square by 2, right? Plus 100 into x minus 4 raised to 0. So it will become 100 into x minus 4 raised to 0 plus 1 by 0 plus 1. So it will be x minus 4 raised to 1 by 1. So we just keep it like this. Now this I will call it as equation 1. Or again we get ei into y is equal to, now 50 by 2 will become 25, x square will become x cube by 3, or rather I will just copy this entire expression and I will modify here. Okay, I forgot to put the constant, plus c1 will be there, plus c1 plus c2. Okay, this we are done. This is 200 by 2, so this will become 100. This will be x minus 4 whole cube by 3. Now this is 100 into x minus 4 raised to 1. So I will now make this square by 2, right? So, and c1 will become c1x and c2 is the new constant. So call this equation as 2. Now you have to apply the boundary condition in this equation. See, for all the simply supported beam, we will have the same boundary condition. Boundary condition. What is the boundary condition you apply? At x equal to 0. What is x equal to 0? That is at point A, right? When at point A, that is the support A, the deflection will be 0. Y will be equal to 0 at support A. In equation 2, always try to apply the boundary condition in equation 2 only for simply supported beam. For cantilever, we will also use equation 1. Okay, so here it will be we'll be using only equation number 2. That is the final equation that we get. Okay, we get, now y is 0, so this will become 0 equal to x is 0, so this will be 0 minus 0 plus 0 plus again 0, right? So wherever there is x, all those terms will become 0 because it is here it is directly 0 into 25. Here it will become negative. So whenever the term inside the bracket is becoming negative, we will just put it as 0 or we will drop those terms. And we will have the constant plus C2 or C2 is equal to 0. In most of the cases for simply supported beam, you will get C2 0 only. Very rarely you will get the value for C2. Now we'll apply another boundary condition. Boundary condition at x equal to L equal to 6 meter. y is equal to 0. That is support B, right? So this is B. At the supports, the beam deflection will be 0. Basically, that is what I am saying here. In equation 2, we get, okay. Now again put y is 0 here, so it will become 0 equal to 25 x cube by 3. So I'll just copy this equation. C2 has become already 0, so I don't need that. Now I just have to put x as 6 meter. So this is 6 cube. This will be 6 minus 4, it is positive. This will also be 6 minus 4, that is also positive. And this will become 6 C1, right? Now let me just calculate this. 25 into 6 cube by 3 minus 100. 6 minus 4 is 2. 2 cube is 8. 100 into 8 by 3 plus 100 into 6 minus 4 is 2. 2 square is 4. 100 into 4 by 2. So this is 1733. This is on the right hand side. When it goes on the left hand side, it will become negative by 6. So it is 288.888. So I'll just write, or C1 is equal to 288.88, and it will be negative because it was positive here. When it goes on the other side, it will become negative. Now put value of C1 and C2 in equation. What is asked in this? Find the deflection at C for the beam loaded as shown in figure. Take EI is equal to 40,000 kilonewton meter square. So we will also find the slope, right? In the question he has asked only deflection. I will find slope also. Now put value of C1 and C2 in equation 1 and 2. We get so this is my equation 1. Just copy it here and paste it here. So I'll remove EI from here. Dy by dx is equal to 1 by EI into 50x square will become 50 by 2, so it will become 25 x square minus 200 by 2, so it will be minus 100 into x minus 4 whole square, right, plus 100 into x minus 4. This will be as it is. Plus C1 is there, and C1 value is minus 288. So it's just minus 288. This part, right? And I will call this equation as 3. Similarly, I'll take this expression till here. Okay, so this will be 1 by EI, again open a bracket, 25x cubed by 3. I'll just put this entire thing inside. Right? So this I'll not change. 100 by 3, that will also become fraction. This I can definitely change. So this will become 100 by 2 is 50 x minus 4 whole square. This is minus 288.89 x. I missed the decimal, right? And this we will call it as equation 4. Okay. Now I need to find the slope and deflection at point C. At point C, x equal to 4 meter, right? So I have to put x equal to 4 meter in this. I will just copy this. 1 by EI. EI value is given as 40,000 kilonewton meter square. So just put that value here, 40,000. X is 4. So just put the value of x as 4. This will be 4 minus 4. So this term will become 0. This will also be 4 minus 4. So this term will also become 0. And this is a constant, so it will remain as it is. This will be in radians. Let us calculate this. 25 into 4 square is 16 minus 288.89 divided by 40,000. So the 0.00278 radians. If you want, you can convert this into degree also, but in most of the books I have seen they have just kept it in radians. So it is up to you what you want to do. You can keep it in radians or degree. Deflection at point C, x equal to 4 meter. We will use this expression. Y is equal to 1 by EI. EI is 40,000. This will be 4. Again, 4 minus 4 will become 0. 4 minus 4 will become 0. So these two terms, you can just drop it. Here it will be there. Okay. So this is the deflection. That is equal to 25 into 4 cube minus 288.89 into 4. So this is a positive deflection. So 0.0111 meter. Or 11.11 mm, right? So that is the deflection and it is positive. So that means the beam will be having a hogging bending, right? It will bend like this because of this couple, right? So this is the solution to this numerical.